In this lesson, we are going to learn about rational exponents. We are going to be in section 7.5 in your textbook on page 603. We are going to work on numbers 2 through 18 and 22 even, numbers 24 through 32 even, and then numbers 34 through 76 even. So in this section, we are going to find out what happens when we have a fraction for an exponent. So we always start with a number that is our base, and then you always have an exponent for that base, whether it's written or not. Well, we're going to be dealing with exponents that are fractions, so we need to find out what each numerator and denominator mean. So we say our base is our power over our root. If it helps you at all, and I'm not trying to impose on anybody's religious beliefs, but the way I remember this is that God is the almighty power, so he is up above, and then roots, they grow in the ground, so they're going to be below. However you would like to remember it is definitely up to you. So we're going to need to translate this exponential form into radical form. So in radical form, this would be our root. You also should know it as the index. Your base would go down here. And then your power is your exponent to the base under the radical. So on number 2, we have 100 to the 1/2 power. So we're going to want to translate this into radical form. So to translate this, we're going to write our radical. 100 is our base, so it goes down under the radical. The power is the numerator. So you see over here in our diagram that the power is the exponent for your base. And then this bottom number is the root. And we see that the root in our diagram goes where the index is. So that's 2. So if we were to read this problem, we would actually have the square root of 100, which is 10. Number 4 says I have negative 81 to the 1/2 power, and negative 81 is in parentheses. Let me make that to where y'all can read it a little bit better. So when we translate this problem, negative 81 is our base, our power is 1, and our root is 2. So the entire negative 81 was put under the radical because it was in that set of parentheses. So that means that you are raising this entire negative 81 to the 1/2 power. As you learned in section 7.1 notes, you cannot take the square root of a negative number because there are no two numbers that multiply to give you an odd number. Some people might want to say that the answer would be negative 9, but if we did negative 9 times negative 9, we would end up with a positive 81, and our goal is to get negative 81. So your answer for this problem could be one of two answers. You could either write not real, or you can write imaginary. Either answer is perfectly fine with me. So now let's move on to number 6. On number 6, I have negative 49 to the 1/2 power. So when I have negative 49 to the 1/2 power, notice the difference between this problem and the one we just did. This one is missing the parentheses. So if I were to translate this, that negative is not being raised to the 1/2 power. The only thing we're raising to the 1/2 power is that 49. So the negative has to stay on the outside, and then 49 goes on the inside. Power is 1, root is 2. So what they're asking you here is what is the opposite of the square root of 49? Well, the square root of 49 is 7. So if they ask for the opposite of 7, then that would be negative 7. Moving on to number 8. I have negative 64 to the 1/3 power, and that negative 64 is in parentheses. So that means that the negative 64 goes inside of the radical. Exponent is 1. The root is 3. So they're asking for the cubed root of negative 64. Again, if you remember what we went over in 7.1 lesson, we can have the cubed root of a negative number because a negative times a negative times a negative will give us a negative number. So that means that we can take that cubed root of a negative, which would give us a negative, and then the cubed root of 64 is 4. So negative 4 is our final answer. Number 10 says I have negative 81 to the 1/4. And that negative 81 is not in parentheses. So remember that the negative stays on the outside of the radical. 81 goes under the radical. Power is 1, and the root is 4. So they're asking us for the opposite of the 4th root of 81. Well, the 4th root of 81 is 3, because 3 times 3 times 3 times 3 gives us 81. And then they ask for the opposite of that. So the opposite of that would be negative 3. Number 12, I have 27 over 8 to the 1/3 power. So remember, everything inside of that parentheses is going to be raised to the 1/3 power. So I'm going to go ahead and draw my radical, and I kind of want it to be what I call 2 stories because you're going to need 2 different spaces. The root is 3, and then I have a 27 to the 1st over an 8 to the 1st. Remember, so the 27 and the 8 both get the power, and they're both being taken of the 3rd root. So the 3rd root of 27 over the 3rd root of 8, we learned we could break these apart in section 7.1 notes. So the cubed root of 27 is 3, the cubed root of 8 is 2. We are now finished. Number 14 says I have 16 to the 3/2 power. This problem is a little bit different. So let's make sure that we pay attention here. So to translate this, 16 is my base, my power is 3, and my root is 2. So they're asking us for the square root of 16 to the 3rd power. Well, we can do this a couple of different ways. We could multiply 16 by itself 3 times and get an obscenely large number. We don't want to do that. We could also take these 16s and do our prime factorization trees and then pull out all of the common numbers that we can. Or we can do this the easiest way, which would be to at first cover up your power. So we would ask, what is the square root of 16? Your answer would be 4. So I'm going to write equals 4, and I'm going to take this power of 3, and I'm going to put that with my 4. So 4 to the 3rd power is 64, and now you're finished. So I challenge you to try and pause this video and see if you can do numbers 16, 18, and 22. Remember at the beginning of the video we said that we are not going to do number 20. By the numbers that I gave you in the beginning of the lesson, I did not require you to know how to take the root of a number that large. So no worries on number 20, but go ahead and try and get number 16, 18, and 22 down. So you can go ahead and pause the video if you would like to do that yourself. So on number 16, we have 64 to the 2/3 power. So to translate that, I would have 64, my power is 2, my root is 3. So remember, you can cover up that exponent. So the cubed root of 64 is 4, and then you take that exponent of 2 and put it with that 4. So 4 squared is 16. Number 18, I've got negative 81 to the 3/4 power. Remember, since that negative is not in a parentheses, it has to stay outside of the radical. So my power is 3, my root is 4. So I need to find out what the 4th root of 81 is. You should get, oops, sorry, I'm covering up the 1. What the 4th root of 81 is, and that would be a 3. So don't forget to write this negative here. So that would be negative. And then I have 3, and I'm going to bring it to the 3rd power. So I'm only raising that 3 to the 3rd power. The negative isn't included. So I'm just going to bring that negative down, and 3 to the 3rd power is 27. The only way that we would have included that negative and done negative 3 times negative 3 times negative 3 would have been if this was in parentheses. Since it was not in parentheses, then we were only cubing that 3. Now let's look at number, 22. So on number 22, I have 16 over 9 to the 3/2 power. One second, I'm starting to run out of lead. There we go. So it's 16 over 9 to the 3/2 power. So what I'm going to do is I'm going to write my radical sign. My root is my denominator, so I'm going to go ahead and put my 2 there. Well, my 16 has the exponent of 3, and my 9 has the exponent of 3. Remember, whenever you have a fraction and you're raising it to a rational exponent, which is an exponent with a fraction, you've got to remember that each one of these gets that fraction. So they're all being taken to the square root, and then the 3 has to go to the 16 and the 9. So the square root of 16 would be 4. I'm going to bring my 3 over. And then the square root of 9 is 3. I'm going to bring my 3 over. So that gives me 4 to the 3rd power is 64 over 3 to the 3rd power is 27. Now we're going to move to objective 2 on this page. The directions say to evaluate each expression. They do say to use a calculator to check your results. However, in this class we know that we are not to use a calculator, so we're not going to do that step. But basically in this section we're going to look and see what happens when we have a negative exponent. So on 24 I've got 27 to the negative 1/3. If you recall, whenever you have a negative exponent, I always teach you to circle your base, which is the 27, and the exponent that's negative. Then you move it to what I call the other side, and the other side of a fraction from the numerator would be to the denominator. So I then have 27 to the 1/3, and I can't leave my numerator blank. I have to have some number up there, so I'm going to put it down as a 1, okay? Whenever you do not have a number in your numerator and you need that placeholder, you're always going to put it down as a 1. So that gives me 1 over. I'm going to translate that 27 to the 1/3 into that radical form we've been talking about. So that's going to give me a 27 power of 1 and a root of 3. So the cubed root of 27 is 3. So my final answer is 1/3. Number 26, I have 121 to the negative 1/2. Hopefully you can do this problem. We're going to translate that 120, nope, we're not going to translate yet. Sorry about that. We actually have that negative exponent that I really want y'all to take care of first. I just got a little excited there. So we take that 121 to the 1/2 and we move it down to the denominator. So that then makes this 121 have an exponent of a positive 1/2. Once you move it, the exponent is now positive. And remember that placeholder we put at the top is a 1. Now we can translate it. So that gives me 1 over, and I've got the square root of 121. The power is 1, and then that root is 2. So now I've got 1 over, the square root of 121 is 11, and we're finished. 28, I've got 16 to the negative 3/4. So we're going to circle that 16 and the negative 3/4, and we're going to move it down to the bottom. So that gives me 16 to the 3/4 in the bottom. Notice that your exponent is now positive, and we're going to write our placeholder of 1 in the numerator. Now I'm going to translate 16 to the 3/4 in radical form. My power is 3, my root is 4. So they're asking us for the 4th root of 16. So what number times itself? 4 times gives us 16. That answer is 2. And then I'm going to take that 3 and I'm going to put it with that 2. So 2 to the 3rd power is 8. So our final answer is 1 over 8. Number 30, I have 16 to the negative 3/2. So 16 to the negative 3/2, I'm going to circle my base and my exponent. Remember, the reason I'm doing this is because I can't have a negative exponent. So I'm going to put that term down into my denominator. That makes me have a positive exponent, and then I have my placeholder of 1. Now I'm going to translate my 16 to the 3/2 into radical form. I apologize for the cat meows. So 3 is my power, 2 is my root, so that gives me 1 over. The square root of 16 is 4, and then I'm going to carry my root of 3, or I'm sorry, my exponent of 3 to my 4, which gives me 1 over 64. The final problem in this section, or in this objective at least, is going to be number 32. 32 says I have 27 over 8, all to the negative 2/3 power. So we can go ahead and do this a couple of different ways, but with this negative exponent, it makes it a little tricky. So I'm going to recommend that you guys go ahead and distribute that negative 2/3 into each exponent. This would be the easiest method in my eyes. So that gives me 27 to the negative 2/3 and then 8 to the negative 2/3. So since we have negative exponents, we're going to circle the base and the exponent that's negative. And then I draw arrows to where they're going to go. So the 27 to the negative 2/3 starts on the top, so it's going to go to the bottom. And then my 8 to the negative 2/3 starts at the bottom, and it's going to go to the top. So that gives me 8 to the 2/3 over 27 to the 2/3. Now I translate it to be 8, power is 2, root is 3, over 27, the power is 2, root is 3. So the cubed root of 8 is 2, and then we bring that exponent of 2 over. And then cubed root of 27 is 3, and you bring that exponent of 2 over. So 2 squared is 4, 3 squared is 9. We are finished. Next, we're going to look at simplifying these expressions. So this is going to be numbers 34 through 76. Number 34 says I've got a to the 2/3 times a to the 1/3. So you know the rule, when you multiply your bases, you should add your exponents. So that rule is still true when you have fractions. So that means that I'm going to multiply my two a's to just get one a, and I add those exponents. So that would be 2 over 3 plus 1 over 3 is 3 over 3, which is just a to the first. I would accept either a to the first or just a. Either answer is perfectly fine with me. Number 36 says I've got m to the 1/4 times m to the 5/4. So that gives us m to the 1/4 plus 5/4. So you add your numerators. So that gives me 1 plus 5 is 6. And then you keep that same denominator of 4. So I can still simplify that to give me m to the 3/2. Now number 38 is different. On number 38, we have p to the 5 over 6, p to the 2 over 3. What you might notice here is that we don't have a common denominator. And that is the golden rule when you are adding or subtracting fractions. So the common denominator between 3 and 6 is going to be 6. So I'm going to multiply this 3 by 2. And remember, what you do to the numerator, you must do to the denominator. So that gives me p to the 5 over 6. Oops, that's supposed to be a plus, guys. Sorry about that. P to the 5 over 6 plus 4 over 6, which is p to the 9 over 6, which is p to the 3/2. Guys, this problem right here, number 38, is one of the most commonly missed problems on this exam. So please make sure that you guys truly understand this specific problem. Now we're going to look at number 40. Number 40 says I've got a to the 5/6 divided by a to the 1/6. So you may remember the rule that when you divide your bases, you should also subtract your exponents. So I would have 5/6 minus 1/6, which gives me a to the 4/6, which simplified is a to the 2/3. 5 minus 1 gave us 4. You keep the 6. And then if you divide your numerator and denominator both by 2, that gives you your 2/3. 42. I have z to the 9/2 over z to the 3/2. So I'm going to subtract those exponents. So that gives me 9/2 minus 3/2, which is z to the 6/2, which is z to the 3. Number 44, b to the 7/6 over b to the 2/3. So when I divide my bases, I'm going to subtract my exponents. What you're going to notice on this problem is, again, just like on, I believe, number 38. Yeah, number 38 that we did not have a common denominator. So we're going to need to get a common denominator here. So my common denominator here is going to be 6. So I multiply that second fraction by 2 in the numerator and 2 in the denominator. So that gives me b to the 7/6 minus 4/6, which is b to the 3/6, which when simplified is b to the 1/2. Sorry, you can't really read my 2 there. All right, now we're going to look at number 46. On number 46, we have y to the 4/3 times 3/4. And when we raise a power to another power, that means it's multiplication. So we're going to multiply these fractions. So when I multiply these straight across, 4 times 3 is 12. 3 times 4 is 12. So to simplify, that gives me y to the 1st, or just y. Some of you may have been tempted to simplify and cross out these 4's and these 3's to get your y. That is perfectly fine as well. So when we look at number 48, we have p to the 3/4 raised to the 2/3 power. So remember, when we are raising a power to another power, you multiply those exponents. So we can either multiply 3 times 2 to get 6, 4 times 3 to get 12, and then simplify, or we can simplify before we multiply. So we can say that these three simplify to be ones because 3 goes into 3 once, 3 goes into 3 once, and then same thing with 2 and 4. Between 2 and 4, the number 2 goes into 2 one time, 2 goes into 4 two times. So that gives me p to the 1/2. Now for number 50, I've got w to the negative 2/3, all to the 6th power. Now, whenever you're working with fractions, I recommend making everything a fraction. So making that 6 over 1, that way you can see what your numerator and denominator are. So I can simplify that 3 and 6 to be a 1 and a 2, which gives me w to the negative 4. But remember, it's not simplified if it has a negative exponent. So we're going to move that w to the negative 4 to the denominator, which will give me a w to the positive 4. But we still have to have a number in our numerator. And remember, that number we always use is going to be a 1. 52 is slightly different. On 52, I have p to the 3/4, q to the 5/2, all raised to the 4th power. So what we actually have to do is distribute this 4, which means to multiply, and we're going to multiply that by every exponent inside of the parentheses. So that gives me p to the 3/4 times 4 over 1 and q to the 5/2 times 4 over 1. Remember, I'm putting that 4 over 1 so we can see what our numerator and denominator are. So these 4's will cancel, leaving me with just a p, and then that 2 goes into that 4 2 times. 5 times 2 is 10. So I get a p and then q to the 10. If you want to write that 1 there for that p's exponent, oh wait, nope, it was supposed to be a p to the 3rd. Sorry about that, I just hadn't written it. Because when these 4's canceled, that made it 3 times 1 is 3, and then you would have just had a 1 in the denominator. Sorry about that, guys. So now we are finished. So now on number 54, 54 is very important. There's a very important rule we have to make sure we understand here. On 54, I have 3m to the 3/4, n to the 5/4, all to the 4th power. So I have to, again, distribute that 4 on the outside of the parentheses into every exponent inside. You might see only 2 exponents there, but there are actually 3 exponents because a whole number always has an exponent, it just might not be written. If it is not written, it is understood to be a 1. So now I'm going to multiply or distribute that 4 into all of the exponents inside of the parentheses. So that gives me 3 to the 4th, m to the 3 over 4 times 4 over 1, and n to the 5 over 4 times 4 over 1. So 3 to the 4th gives me 81, because 3 times 3 is 9, 9 times 3 is 27, 27 times 3 is 81. And then those 4's will cancel, leaving me with an m to the 3rd. And those n's will cancel, or those 4's will cancel, leaving you with an n to the 5. Number 56, x to the 5 over 2, y to the 5 over 7, all raised to the 2 over 5. So again, as normal, we're going to distribute that 2 over 5 exponent into all of our exponents inside. So that gives me x to the 5 over 2 times 2 over 5, and then y to the 5 over 7 times 2 over 5. So for your x, you'll notice that these 2's cancel and those 5's cancel, leaving you with just an x. And then with the y, you'll notice those 5's cancel, leaving you with just a 2 over 7. If you want to write that x to the first power, you absolutely can. If you don't write the 1, that's fine as well. That is now all the way simplified. For number 58, I have 16, a to the 1/3, and then b to the 2/3, all raised to the 3/4. So remember, if you have a whole number, just like on number 54 up here, if you have a whole number that has no exponent written, that doesn't mean it doesn't have an exponent. It's just kind of invisible, okay? It's understood that there's going to be a 1 there for that 16. So I have to multiply that exponent times everything inside of that parentheses, every exponent inside that parentheses. So that gives me 16 to the 3/4, a to the 1/3 times 3/4, b to the 2/3 times 3/4. So for the 16 to the 3/4, I can actually translate that into that radical form that we talked about in the very beginning of this lesson. So 16 is my base, 3 is my power, 4 is my root. For my a up here, these 3's cancel, leaving me with a to the 1/4. And then my 3's cancel for my b, and then the 2 over 4 simplifies to be 1/2. So to finish this problem, I can take the 4th root of 16, which is 2, and then that 3 is carried outside of that radical. A to the 1/4, b to the 1/2. And then finally I can simplify by doing 2 to the 3rd power, which is 8. Because 2 times 2 is 4, and then 4 times 2 is 8. Okay, so now let's look at number 60. Number 60 is no different from the other problems that we have already worked. Number 60 says I have p to the 5 over 6, q to the 2 over 3, r to the 5 over 3, and then everything is to the 3/5 power. So I distribute that 3/5 into each exponent inside of the parentheses. So that gives me p to the 5 over 6 times 3 over 5, q to the 2 over 3 times 3 over 5, r to the 5 over 3 times 3 over 5. So these 5's will cancel on our p, and then 3 goes into 6 2 times. So that leaves me with p to the 1/2. And notice that it's 1/2 and not 2. The reason it's 1/2 is because your 2 over here is in the denominator, so that means we have to have that 1 in the numerator. Then our 3's cancel here, leaving me with q to the 2 over 5. And then for my r, my 5's and my 3's cancel, leaving me with r to the 1st. If you did not write the 1 for the exponent for the r, that's no problem. It means the same thing. So you don't have to write that 1 for the r, but if you would like to, you are more than welcome to. Now number 62. 62, we're going to have to take one step at a time. I've got x to the 2/3, y to the 3/4 over x to the 1/2, y to the 1/2. So on this problem, when you divide your bases, you're supposed to subtract your exponents, just like we talked about on numbers 40, 42, and 44 in this lesson. But the difference is that we've got to worry about our x's on one part of the problem and our y's on another part of the problem. So we need to get a common denominator here. So to get a common denominator, we've got to look at the denominators for our x's. So I've got a 3 up here and a 2 here. So I'm going to multiply that 3 by 2 and that 2 by 3. That'll give me a common denominator of 6 there. And then over here for my y's, I can get a common denominator of 4, which means I'm just going to multiply that denominator's exponent because that numerator already has the 4, so we want to make this one a 4. So that gives us x to the 4 over 6, because 2 times 2 is 4, 3 times 2 is 6, y to the 3 over 4 over x to the 3 over 6. I got that because I said 1 times 3 is 3, 2 times 3 is 6, and then y to the 2 over 4, because 1 times 2 is 2, 2 times 2 is 4. So now we have to take this part of our problem and then this part of our problem. We've got to think about these separately. So 4 over 6 minus 3 over 6, and if you need to see it horizontally. So 4 minus 3 gives us 1, and then you keep your denominator of 6. So that leaves us with x to the 1 over 6. And then we have the 3 over 4 minus 2 over 4, which is 1 over 4. So we have y to the 1 over 4. And we are finished. Okay, so that was number 62. So now we're going to work on number 64. 64 says we've got w to the negative 2, z to the negative 1/4, all to the 6th power, over w to the negative 8, z to the 1/2. Okay, so you might think, well, let's go ahead and move all of our negative exponents so that takes care of those and they're out of the way. I do not recommend moving your negative exponents until after you have distributed any of your powers to a power, because had that 6 been a negative, you would have ended up having to do everything over again. So let's go ahead and distribute this 6 into everything in the parentheses. Notice that we only have parentheses in our numerator, so that is all that the 6 is going to go to, is what's in the numerator. So that gives me w to the negative 12, z to the negative 6 over 4, because that's 6 over 1, so 6 times negative 1 is negative 6, 4 times 1 is 4, over w to the negative 8, z to the 1/2. Before I move on, I'm going to go ahead and simplify that z to the negative 6 over 4, which gives me w to the negative 12, z to the negative 3 over 2, over w to the negative 8, z to the 1/2. So now remember, we circle the bases and the negative exponents that are attached to them. So I'm going to circle that, circle that, I'm going to circle that. Notice how I didn't circle the z to the 1/2. The reason I did not circle that one is because we have a positive exponent already. So if I were to move it, that would make my exponent then a negative. So I've drawn my arrows to where everything goes. Remember, if it's in the numerator, it automatically goes to the denominator. If it's in the denominator, it automatically goes to the numerator. So I'm going to end up with w to the 8. Oops, I messed up. Sorry about that, guys. I've got a w to the 8 that goes on the top. My w to the negative 12 goes on the bottom and becomes a positive. Then I have my z to the 1/2 that didn't move, and my z to the 3/2. So now I'm going to take this one step at a time. I'm going to look at my w's first, and then I'm going to look at my z's. So when you divide your bases, you subtract your exponents. So 12 minus 8 gives me 4, but that answer is going to go in my denominator. The reason it's going to go in my denominator is because there are more w's in the denominator than in my numerator. So I'm going to come over here because I'm out of room, and I'm going to have a w to the 4th in my denominator. And then over here, we're multiplying our z. So when you multiply your bases, you add your exponents. So 1/2 plus 3/2 gives me 4/2. And then that simplifies to be 2. So that gives me z squared because it was on the bottom, so we're going to keep it on the bottom. And remember, if there's nothing up top, then you do need to have that placeholder. So that is my final answer. Now moving on to number 66. I have q to the 12 over p to the 28. And they're all being raised to the 1/4 power. So we're going to multiply that 1/4 times everything inside of that set of parentheses. So even though I've got stuff in the numerator and the denominator, I can still multiply that 1/4 by everything because of those parentheses. So I have q to the 12 over 1 times 1 over 4 divided by p to the 28 over 1 times 1 over 4. So I can simplify the 4 into the 12 to be 3, the 4 into the 28 to be 7. So I have q to the 3rd over p to the 7. Now, number 68. I have r to the 1/5 over s to the negative 1/2. And it's all being raised to the 10th power. So remember, I recommend that you go ahead and distribute first and then move your negative exponents. So I'm going to multiply this 10 times every exponent inside of my parentheses. So that's going to give me r to the 1 over 5 times 10 over 1 divided by s to the negative 1 over 2 times 10 over 1. Remember, we put the 10 over 1 so we can see what our numerator and denominators are. So the 5 goes into 10 2 times, 2 goes into 10 5 times. So I'm left with r squared over s to the negative 5. Now I want to move that s to the negative 5 to the other side, which in this case is the numerator, which gives me r squared s to the 5th over 1. You do not want to leave this answer over 1 because that is not simplified. Simplified would mean that you would not leave it over 1 because you can still take it one step further. And it does matter whether the R or the S comes first. You always put your variables in alphabetical order. Oops, sorry about that. So since R comes before S in the alphabet, that's the order we're going to put it in. So now let's look at number 70. Number 70 says I have A to the 1/3. I'll put something down here so it doesn't keep flying. So I have A to the 1/3, B to the negative 1/6, over C to the negative 1/6. And this is all being raised to the 6th power. So I multiply that 6 by every exponent inside of that set of parentheses, which gives me A to the 1/3 times 6 over 1, B to the negative 6 over 1, sorry about that, B to the negative 1 over 6 times 6 over 1 over C to the negative 1 over 6 times 6 over 1. So again, 1/3 times 6, and we do it over 1 so we see our numerator and denominator. B to the negative 1 over 6 times 6. And then C to the negative 1 over 6 times 6. So now I can simplify. 3 goes into 6 2 times. These 6's cancel, and these 6's cancel. So that leaves me with A squared B to the negative 1 over C to the negative 1. But that isn't simplified because we can't have a negative in our answer, or at least a negative exponent. So we are going to move these to the other sides. So my A squared stays in the numerator. It doesn't change because it's a positive exponent. But my B to the negative 1 is going to go down to the denominator. So when you move it down to the denominator, it becomes a positive 1. And then C to the negative 1 is in the denominator. To get rid of the negative, you would move it to the numerator. So that gives me C to the positive 1. Again, if you do not write the ones for your exponents, that is okay. There's no problem with that. Okay, so now let's look at number 72. I've got 16p to the negative 4. Q to the 6 over r squared. And that's all raised to the negative 1/2 power. So this is a prime example as to why you would not want to go ahead and move that p to the negative 4 to the denominator. The reason is because since this exponent is negative, that means it's going to change all of those exponents and their signs. So remember, your 16 has an understood exponent of 1. And then I distribute this negative 1/2 into all of my exponents. So that gives me 16 to the negative 1/2, p to the negative 4 over 1 times negative 1 over 2, q to the 6 over 1 times negative 1 over 2, over, oops, that's not the right letter, r to the 2 over 1 times negative 1 over 2. So let's go ahead and multiply what we can, and then we'll move the negative exponents where they need to go. So I'm going to go ahead and leave that 16 to the negative 1/2 alone. Well, 2 goes into 4 2 times, and a negative times a negative is a positive, so that gives me p squared. So it's p to the positive 2. This 2 goes into this 6 3 times, so that gives me q, and then 3 times negative 1 is negative 3 over. These two simplify, leaving me with r to the negative 1. Okay, so now I'm going to circle all of my variables with the negative exponents. And move them to the other side, so that p squared stays up top and the r to the first moves up top because it was in the bottom, so we're going to move it to the top. Now my 16 to the 1/2 is now in the denominator. Started in the numerator. To make the exponent positive, we moved it to the denominator. And then the q to the negative 1/3, we're going to move that to the denominator, and it's going to become a q to the positive 1/3. Now the only thing we have left to do is evaluate that 16 to the 1/2, which we would translate that into that radical form. Oops, sorry about that swift movement, guys. So that gives me p squared r over the square root of 16 is 4, and then we have our q to the 3rd. Okay, number 74. Says I have 27 x to the 5/6, y to the negative 4/3 over x to the negative 7/6, y to the 5/3. And that is all being raised to the 1/3 power. So the 27 has an understood 1, and I'm going to distribute that 1/3 into every single exponent inside of that set of parentheses. So that gives me 27 to the 1/3 x to the 5/6 times 1/3 y to the negative 4/3 times 1/3 over x to the negative 7/6 times 1/3, and then y to the 5/3 times 1/3. So now I'm going to multiply everything out, and I'm going to translate my 27 into that radical form. So I have x to the 5/18, because 5 times 1 is 5, 6 times 3 is 18. And then that gives me y to the negative 4/9. Because negative 4 times 1 is negative 4, 3 times 3 is 9, over x to the negative 7 times 1 is 7, 6 times 3 is 18, And then y to the 5 times 1 is 5. 3 times 3 is 9. So now I'm going to move my negative exponents, and I should only have to worry about this y to the negative 4 over 9 and the x to the negative 7 over 18. X to the 7 over 18 is going to move to the top. Y to the negative 4 over 9 is going to move to the bottom. So the cubed root of 27 is 3. Then I have x to the 5 over 18, x to the 7 over 18, because this term, or this variable, moves up to the top to make that exponent a positive, over my y to the 5 over 9 stayed down here because it was already positive. And then that y to the negative 4 over 9 moves down to the denominator and is now positive. So now I can go ahead and combine these to get 3. When you multiply your bases, you add your exponents. So 5 plus 7 is 12. Oops. And that has a denominator of 18. And then when I combine my y's, again, when you multiply your bases, you add your exponents. So that gives me y to the 9 over 9, because 5 plus 4 is 9, and you keep that 9 as a denominator. So now all we have to do is simplify those exponents and we're done. So we're still left with that 3 in the numerator. 12 divided by 18. Those two have a 6 that will divide into both of them. So 6 goes into 12 2 times, 6 goes into 18 3 times. So again, we just divided that by 6 and that by 6. And then I have a y to the first, or just a y, because 9 divided by 9 is 1. Okay, so now we're going to move to the last problem in this section, which is number 76. Just so you know, if you were to see any type of problem like this on your exam, it would probably be closer to a bonus problem instead of an actual problem for credit. So when we look on 76, I have p to the 1/2, q to the 4/3, over r to the negative 4, and that's raised to the 3/4 power. And then I have p to the 15 over 8, q to the negative 3, over r to the 6th, and that is all raised to the 1/3 power. So what I'm going to do is I'm going to distribute this 3/4 into all of my exponents. So I'm going to do this parentheses first, then I'm going to do this parentheses. So I'm going to kind of take it a little bit a step at a time. So that's going to give me a p to the 1/2 times 3/4, q to the 4/3 times 3/4, over r to the negative 4 over 1 times 3/4. So I'm going to put all of that in parentheses just so I can separate it from what I have going on here. So I'm going to multiply this side by my 1/3. So that gives me p to the 15 over 8 times 1 over 3, q to the negative 3 over 1 times 1 over 3, over r to the 6 over 1 times 1 over 3. So now I'm going to multiply everything in this set of parentheses. This problem is probably going to take up about 3/4 of a sheet of paper, so just be ready for that. So 1 times 3 is 3, 2 times 4 is 8. So that gives me p to the 3 over 8. And then these 4's cancel and these 3's cancel, leaving me with just a q. And you can write q to the first if you want to. Then these 4's cancel, leaving me with just an r to the negative 3, because a negative times a positive is a negative, and then you've got that 3 times 1 is 3. Then over here, 3 goes into 15 5 times, so that leaves me with a p to the 5 over 8. Then I have my q. These 3's cancel, leaving me with a q to the negative 1 over. This 3 goes into this 6 2 times, leaving me with r squared. So before I do anything else, I'm going to go ahead and get rid of these negative exponents. So this one's go on the top, this one's going to go on the bottom. So I'm left with p to the 3 over 8, q to the 1, r to the 3, because the r moved up top. And I'm just going to put this over 1. Since I still have a fraction in this parentheses, I just want to see what's on my top and bottom. So then I have my p to the 5 over 8. And then I have on my denominator a q to the 1 and an r squared. Now I can go ahead and combine these by multiplying them together. So p to the 3 over 8 times p to the 5 over 8. Well, when you multiply your bases, you add your exponents. So 3 over 8 plus 5 over 8. So 3 plus 5 is 8. You keep your same denominator of 8, which leaves you with a 1. So that gives me in my numerator a p to the 1. And then I've got my q up top, and my r to the 3rd here, over my q r squared. So I'm still not done. I've got q's in my top and bottom, and I've got r's in my top and bottom. So these q's are going to cancel out. The reason is because if you, let's say, have 2 divided by 2, those cancel out and just give you a 1. X divided by x, same thing. They cancel out and just give you a 1. So the same thing happens with q's. So now I have p, and when you divide your bases, you should subtract your exponents. So 3 minus 2 is just a 1. So your final answer for number 76 is PR. Here we go. Back that up just a little bit, just so y'all can see that entire screenshot of that problem if you need it. I hope this lesson has helped you with your rational exponents. Good luck.